Hello, this is an example of how to do integration using an integration technique called integration by parts. Before we begin this particular example, I want to give a little background information to help everyone understand where this whole technique of integration by parts comes from. So if we take the product rule, which is we're going to say f times g and take the derivative of that, okay? Then we know the product rule says that we need to do the derivative of the first times the second plus the derivative of the second times the first. And so if we look at this here, if instead of going forward from having the product of two functions and taking the derivative of it, let's say we wanted to do integration. And in other words, we want to go backwards. So if we integrate this, then we would have this, and we'll make that one and integrate that. Okay? And so coming here, of course, we have f times g, the derivative of that. And so this would be the derivative of f prime g plus, sorry, not derivative, integral of f prime g plus the integral of g prime f. Now, let's say that we wanted to solve for the integral of f prime g, okay? Or we wanted to solve for the integral g prime f. Then here we would subtract either one from both sides. If we look here at the integration by parts rule here, we're seeing that if we take the integral of a function, which is a product of two functions, the function f of x, which is just the original function, and the derivative of another evaluated over a to b, then we get this situation here. So looking at that, we see that this part right here matches what we see here. Okay? So that means we would need to subtract the integral of f prime g from both sides. And if we did that, then we would get integral of f prime g minus integral of f prime g here. Okay? And that would equal integral of f g prime. And so you see, if we were evaluating this, doing a definite integral, then have this from two values, a to b, you'll see that we come up with something very similar to what we have here for the integration by parts. So I wanted to talk about this first to help you understand where it comes from. It's basically doing the reverse operation or reversing a derivative of something that came about via the product rule. Okay? So now we're going to erase this and then begin the example. All right, so now that we got that cleared, let's go ahead and begin this particular example. So looking at integration by parts here, the first thing that you'll see is that we know that the function that we are going to integrate is really a product of two functions where we have a function f of x and a function g prime of x. And we just saw how that comes from the product rule. So if we look here, in order to select this, we need to select the function f of x and the function g of x. And so what we do here is we select g of x by looking at the two products that make up the function that we want to integrate and figure out which one is easiest to integrate. Allow that one to be g of x, and the one that's easiest to take the derivative of, we allow that to be f of x. And so looking at this particular problem here, we could see that we need to start off by selecting what f of x is going to be and what g prime of x is going to be. So here, excuse me. So here we're going to let f just equal to x here. And we're going to let g prime equal to sine of 3x, okay? So in doing that, we see here, if we take the derivative of x, it's just 1, or particularly 1 times dx. So that would just give us dx here. To get to g, we would actually need to do the integral of sine of 3x. Well, the quick way to do that is knowing that for sine, if we do the integral of sine, or the reverse of sine as far as derivatives are concerned, would be a minus cosine 3x, because we know the derivative of minus cosine is sine. But we see we have the chain rule here, and so that if we were doing this, the derivative of the outside would be sine times derivative of the inside. So to account for that, normally this would be 3 times sine 3x, but since we don't have that, we need to divide this by 3 in order to account for the fact that we have a function stuck within a function. And so from here, we see we have f, we have g, we have f prime, and we have g prime. And now we can use our formula here in order to figure out what the integral of this is by doing integration by parts. So from here, we are going to say the integral from 0 to pi over 2 of f g prime dx is going to be equal to f times g, all that evaluated from 0 to pi over 2, minus the integral from 0 to pi over 2 of g f prime dx. And so here we're just going to fill in whatever f is, whatever g is, and whatever f prime is here. So we know f here is just represented by x. G will be represented by minus cosine 3x over 3. So to incorporate that, we'll put a negative sign there. Cosine of 3x divided by 3, like that. And we'll evaluate that from 0 to pi over 2. Minus integral from 0 to pi over 2. And so now we need to write in g. G would be a negative cosine 3x over 3, which here we can go ahead and adjust that and make that a plus. Put the 1/3 on the outside, and then do cosine of 3x. And then the f prime dx part is just the dx. And so we'll rewrite this, the first term here, noting that that's evaluated from 0 to pi over 2. And now we're going to integrate cosine 3x. So we know the integral of cosine is sine, but again, since we have this 3x in here as function stuff within a function, so we need to account for the extra 3 that we would get if we went back and did the derivative of sine of 3x. We would get 3 cosine 3x. So here we need to divide again by 1/3 sine of 3x. And since these two are constants, we'll leave those out and just evaluate the sine 3x part from 0 to pi over 2. And so from here, we just need to go ahead and evaluate each particular term here from pi over 2 to 0, and then get our answer. So next we'll clear this out, give us some room, and finish up this problem. All right, so we've made a little room, so let's go ahead and complete doing this problem here. So we're going to take this first term here, evaluate for pi over 2, and then turn around and do it again for 0. So we come here first, and this will be minus pi over 2 divided by 3 cosine 3 times pi over 2, which is just 3 pi divided by 2, and then minus, here for the second term, whenever we plug in the 0, we know that since we plug in x of 0 here, anything times 0 is 0. So have that, then plus 1/9, and we do the same thing again here with pi over 2. So this will be sine of 3 pi over 2 minus 0 again. So cleaning this up, this would be minus pi over 6 times this cosine of 3 pi over 2 here would just end up being 0 minus 0. Again, that is a 0 plus 1/9. Sine of 3 pi over 2 is just a -1. So that would be -1 minus 0 there. And of course, this whole term here is 0, and -1 times 1/9 is -1/9. And our answer ends up being a -1/9. So we take the integral of x sine 3x dx and evaluate it from 0 to pi over 2. What we get here is a -1/9, which means that the net area between what was above the x-axis and below the x-axis favored a little bit below the x-axis here. And so this concludes this example of using integration by parts.